Hi students, in this video we are going to learn about equation of a plane in space. Actually we have different forms of equation for the plane. In this video we are particularly going to see about Cartesian form. Cartesian form means using the coordinates x, y, z like that. Right now we will get into the concept. Now we need to consider a plane which passes through the point A. That is, the coordinates of A are x1, y1, z1. With respect to x coordinate, y coordinate, z coordinate, there is a point A whose coordinates are x1, y1, z1 through which this plane passes, and we are considering that plane. And we are considering a vector n vector perpendicular to the plane. Now we are considering a vector which is perpendicular to the given plane. We know that when the vector is perpendicular to the plane, it can be called as normal vector. Hence we have written this as this vector n vector is called a normal vector. And let A, B, C be the direction ratios of n vector. This is very important. We normally denote normal vector's direction ratio as A, B, C only. These are the numbers. You already learnt what is direction ratio, what is direction cosines. They are numbers. They are A, B, C. They are denoted as A, B, C. So in this chapter, whenever we talk about A, B, C, which means that we are talking about direction ratios of the normal vector. Normal vector means that vector is perpendicular to the plane. When direction ratios are given, we know how to convert that into vector. So we can write n vector as A I cap plus B j cap plus C k cap. Now we are considering a point P whose coordinates are x, y, z. Be any point lying on the plane. Actually this is a plane. In this plane we are taking an arbitrary point. We do not know what is its coordinate, so we assume it as x, y, z. This point P can lie here. It is an arbitrary point, but this point lies on the plane. And why do we need to consider this plane? This point is when we write the equation of the plane, in which definitely we must have x, y, z variables. Only when we have x, y, z variables, we can check if a point is given, whether the point lies on the plane or not. For example, if the equation of the straight line is 2x plus 3y is equal to 7, definitely in the equation of the straight line we must have x and y. Then only when the coordinates of a particular point is given, we can find out whether the point lies on the straight line or not. Similarly, in the plane equation also we must have x, y, z variable. Then only we can find out, when a point's coordinates are given, whether the point lies on the plane or not. Hence, in order to bring x, y, z in the equation, we are considering an arbitrary point, but that point must lie on the plane. Let P be any point lying on the plane and whose position vector is r. R vector is the position vector of P. When we know the coordinates, we know how to write it in the vector form. Hence we can say r vector is equal to xi cap plus yj cap plus zk cap. Now if you consider the diagram, point A, actually through this point A only the plane passes, hence point A lies on the plane, as well as we considered an arbitrary point P, hence these 2 points lie on the plane. When 2 points are given, we can make a vector using this. Let us say A is the initial point, P is the ending point. Using this we can make a vector, that is AP vector. AP vector will be equal to x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. So AP vector lies on the plane. Already n vector is perpendicular to the plane, means definitely the n vector is perpendicular to AP vector also. When two vectors are perpendicular, we know that dot product of those two vectors must be equal to 0. This we learnt in vectors concept. So AP vector dot n vector equal to 0. AP vector is position vector of P minus position vector of OA dot n cap. We already know how to form this AP vector: x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap dot this n vector. N vector is represented as A I cap plus B j cap plus C k cap. Already we learned how to do the dot product, that is coefficient of I should be multiplied with coefficient of I, then coefficient of j should be multiplied with coefficient of j, plus coefficient of k is multiplied with coefficient of k. So we are multiplying. After that, this a can be multiplied inside the bracket. Similarly, b and c can be multiplied inside the bracket. When we simplify it, we can extract this form, that is ax plus by plus zz minus ax1 minus by1 minus c z1. When we take minus from all those things concept, we are getting this. Now we can transfer this to the opposite side. Now if you look at this, a, b, c are direction ratios of the normal, hence they are numerical values. X, y, z are the coordinates of the point P. They are arbitrary points coordinate, and this a direction ratio, that is numerical number. X1 is a x coordinate of point A, that is it is a numerical number. Hence ax1 is a numerical number, by1 is another numerical number, cz1 is another numerical number. This we got using dot product. Definitely this must be a length, because dot product produces projection of one vector on another vector. Projection of one vector on another vector means it is a length. Length is denoted as d. Definitely length must be positive. That's why d is equal to ax1 plus by1 plus cz. Actually we are representing ax1 plus by1 plus cz1 is a numerical number. That numerical number is denoted as d, and it is a non-negative real number because it is a length. Length can be 0 or positive. It can never be in negative. That's why it should be non-negative real number. So this is the general equation of Cartesian equation of the plane when direction ratios of the normal vector a, b, c are given. So now I conclude this conclusion: if a, b, c be the direction ratio of a vector normal to the plane, so direction ratio of the normal vector will be given in the question. Then after giving this direction ratio, we will be asked to form the equation of the plane in Cartesian form. The Cartesian form equation is ax plus by plus cz is equal to d, where d is the distance which is given by a into x1 plus b into y1 plus c into z1. So when the question is asked, they will give you direction ratio and the point through which the plane passes. Here the plane passes through x1, y1, z1. These coordinates, x coordinate, y coordinate, z coordinate values will be given in the question, and direction ratios a, b, c also will be given in the question. Based on these two information, we can write the Cartesian form of the plane equation, that is ax plus by plus cz is equal to d, where d is some non-negative real number. This equation is called Cartesian equation of the plane. You just compare this Cartesian equation with the plane with general equation of your plane. Both of them appears to be similar. Only thing is d comes in the right hand side, but d must be positive here. You know already why this d must be positive. So there is a slight difference between general equation of the plane and Cartesian equation of the plane. I hope you understand the formula derivation. Just what we need to remember is, when the direction ratio of the normal vector, please listen carefully, direction ratio of the normal vector and the point through which the plane passes is given, means the coordinates of the point is x1, y1, z1. Those two values are given, means we can write the Cartesian equation of the plane, that is ax plus by plus cz equal to d. Now you know why x, y, z variables are present, because some point is given, means coordinates of the points are given, means we can substitute it in the place of x, y, z and we can check whether it satisfies the equation or not.